Well, hi, good afternoon, everyone. My name is Patty Monahan. I'm Commissioner at the California Energy Commission and for Transportation, which makes perfectly suited to help facilitate this great panel. So I'm joined today with representatives from WattEV, NextEra, Energy Resources, EPRI, and SoCal Edison, and they're going to introduce themselves in a minute. So as the lead for transportation at the Energy Commission, I want to first take note of all the successes that we've accomplished recently. So we hit two big milestones for electric transportation 2 years ahead of schedule. Governor Brown set a goal of having 1.5 million EVs sold and 10,000 fast chargers installed by 2025. So we reached 1.5 million EVs in April, and just last week we celebrated hitting 10,000 DC fast chargers. And in the second quarter of 2023, a whopping 1 in 4 new vehicles sold were electric. California is truly leading the way on all sorts of fronts when it comes to clean energy and zero-emission transportation. But we have a long way to go. We have very aggressive goals as a state to reach a 100% zero-emission transportation system over the next 15 to 25 years. And we have a long way to go to make sure that as we electrify transportation, these vehicles are what we like to call good citizens of the grid. So we really want to be able to plug them in when we have a lot of renewable energy that we would otherwise curtail and literally run these vehicles on sunshine. So I'm looking forward to the discussion today that we're going to have with my fellow panelists. And I'm going to give each panelist 5 to 7 minutes to introduce themselves, provide a quick overview of their organization, and then share their perspective about the EPIC projects that they have been recipients of and talk about the technology or innovation that is being addressed by their research. So I'm going to name all my panelists now and then give them each a chance to introduce themselves. So we're going to start with Salim Youssefzadeh. Sorry for messing up your name, Salim, who is the CEO of WattEV. The second is going to be Ben Gossen, who is an account manager for NextEra Energy Resources. Third is Krish Gomatom, who is a technology and lead manager at EPRI. And last but not least, we have Jordan Smith, who is a consulting engineer with SoCal Edison. Let me turn it over to Salim.
Thanks so much, Commissioner. Good afternoon, everyone. I'm Salim Youssefzadeh, CEO of WattEV. Happy to share with you our story and what we've been doing on the EPIC project. We do have some slides that should be coming on the screen right now. Great. Yeah, so WattEV was founded several years ago with the goal of electrifying the transportation industry. And towards that, we've been putting together a complete ecosystem solution of not only building out charging infrastructure along major trucking corridors, but also putting trucks on the road as a service to really make electric transport a lot more accessible to owner-operators and to shippers that have sustainability goals, but don't necessarily want to deal with the upfront costs or a lot of the barriers to entry. If you go to the next slide. So the key project that we want to go over today was the WattEV Bakersfield site. And this is actually, funny enough, the first site that we took under contract when we started WattEV. And it's the last of the 4 that we've been working on to probably go online. And that's due to its unique nature and true magnitude of the project. So when we started with this Bakersfield site, we wanted to create a truck stop that was modeled after a traditional diesel truck stop. And what that means is that, if you wanted to fuel up 200 trucks per day, what does that correspond to in energy? And that comes out to roughly 25 megawatts of capacity needed to be able to charge 200 electric trucks per day. But 25 megawatts isn't accessible or found in most of the utilities. And the utilities just aren't at that level right now to have 25 megawatts of capacity readily available to anybody that comes along. And this proposed a number of challenges. So we wanted to couple this with solar and battery storage to see if we can utilize distributed energy resources to bring down our reliance on utilities and to bring down the cost of energy and to make it more available to us at that time. So we don't have to necessarily wait for grid uploads to be online. So this project was awarded $5 million grant by CEC, $1 million from Best Fit and $4 million from Epic. And we'll be putting in MCS and CCS chargers in its first phase. So we're doing more of a phased rollout where we're starting with 5 megawatts of solar capacity and then scaling up as the demand increases. If you go towards the next slide. So when we started with the project, we worked very closely with utility, and the initial goal was to sort of create a interconnection agreement with the utility where we can deploy solar and then upload any excess capacity onto the grid. What we soon found out was that the Charge Ready program doesn't necessarily allow for distributed energy resources to go into it. And rather than going down the path of doing a full interconnection agreement, which would take several years for the utility to do the study, we decided to see if we can operate under an islanded operation to have a set of chargers that are just being utilized by solar and battery storage. So we started looking at solar manufacturing companies, came up with a unique solution offered by an Australian company called 5B, which goes with an accordion style layout and is on an east to west inclination rather than using single axis tracking. This allowed for a much faster deployment of solar at a much lower cost from labor standpoint. And then a number of challenges presented to us in terms of how to effectively manage the solar and use it towards the chargers. What that meant was creating a software-driven energy management system that can really analyze what the amount of power is available, what the demand is from the chargers, and then to not use battery storage as a means of charging vehicles in outside daylight hours, but more as a way to create resiliency from the grid and do grid forming and to allow for a soft landing. So what that means is that if a vehicle is charging while it's sunny and then all of a sudden a cloud passes and you all of a sudden lose any capacity, rather than just completely shutting down that charger, it uses the battery storage to create a soft landing where it ends the session peacefully rather than abruptly. And then the chargers themselves would still be operational. And then this led to advancements in the energy management system where we have to create the resiliency, again, do the grid forming and to avoid any black starts. And black starts means the initial connection process of when you have to bring the solar and system online. So we want to avoid doing that as well by having the battery storage. So this project right now is towards the end of its completion on the first phase. Again, we've got 5 megawatts of solar going in, about 3 megawatt hours of battery, and this is going to charge directly towards 15 CCS 240 kilowatt chargers, and then 3 MCS chargers when that technology becomes available. And then on the property, we also have a set of chargers going directly towards PG&E. So from a project standpoint, this allows us to test many new technologies and really see how islanded operations work for solar charging. If you go to the next slide, there's a number of lessons learned. First off, never underestimate what it takes to actually go through the engineering and permitting process. This site was a completely greenfield site, so it took a fair amount of effort to go through the grading, engineering, and entitlements needed to get this project started. Again, on the Charge Ready program side, right now there really is no flexibility to have an interconnection agreement, even though there are some clauses that say that the utility may not be able to guarantee power available. And then from a DER standpoint, again, it's just not set up right now to have any sort of solar or battery storage charged integrated to the Charge Ready program, because Charge Ready is really focused mostly on looking at accommodating just a set of chargers and not having any other load besides those chargers on that program. And then again, lastly, never underestimate the power, right? Again, 25 megawatts of capacity is no small amount. And utilities just right now aren't ready to supply any of that power. And having utilities go through that process of upgrading the lines can take several years. So definitely start the conversations with utilities early in locations that you're looking to electrify, and then build projects to scale, right? So we've started with a small scale on this one where we're going with 5 megawatts and then scaling that up as the demand picks up. and also allowing for new technology advancements where we have both CCS chargers going in the ground as well as MCS when that technology becomes available, so that we can accommodate faster charging in the future. So that's the last slide, and looking forward to the questions. Thank you, guys.
All right, thanks, Salim. Let's turn it over to Ben from NextEra Energy Resources.
Hey everyone, my name is Ben Goossen. I'm an account manager with NextEra Mobility and support all aspects of early stage EV infrastructure project development for our commercial and public fleet customers. Before I get started, just want to thank the commissioner and thank the CEC for having me. I think we've got a great panel today. If you want to go to the next slide. So for those unfamiliar with NextEra Energy, this slide provides a brief overview. NextEra, for those who don't know, is the largest producer of wind and solar energy in the world, and we're made up of two primary entities. So on one side, we own Florida Power and Light, which is the largest electric utility in the US. And then on the deregulated side, the NextEra Energy Resources, who I work for, essentially works in all areas outside the US. We're one of the largest infrastructure investors in the US. We deploy something like $10 to $15 billion in capital every year. And we've made a huge commitment to EV infrastructure as well. Recently, having committed a combined $650 million to highway charging with Daimler Truck and BlackRock. We are really committed to real zero. We have one of the most ambitious net zero targets. And as part of that, you want to go to the next slide, please. We really see transportation as one of those last truly hard to abate sectors. Transportation makes up close to 30% of greenhouse gas emissions in the US, and motor vehicles make up the vast majority of those emissions. So we're trying to not only help decarbonize ourselves, but also reduce and eliminate carbon emissions for our customers. And to do that, we have to be able to provide solutions to help fleets navigate the entire fleet electrification journey. So we really have the ability to meet fleets wherever they are, to help them develop a plan for fleet electrification if they don't already have one. And then finally, to help them design, build, and execute on charging infrastructure deployments to help their operations electrify. Next slide, please. So at our core, again, we're not a technology manufacturer, but we're an infrastructure developer. And what we've seen in the fleet space is that scale really matters, right? So if you're just looking to install one or two chargers, you can do that pretty easily. And that's what we've seen from most fleets is the facility manager and the fleet manager can get together and install a couple of chargers. But when you start talking about electrifying at scale, you start talking about electrifying, going from 3 to 300 to 3,000 vehicles. It becomes a complex challenge. And what fleets are really looking for is that well thought out solution. And that's what we really think we have on the infrastructure side. So going left to right there, again, software support to help fleets plan where and how it makes sense to electrify, but then also supporting a variety of operational fleet needs. So I mentioned the joint venture with Daimler Truck to support highway charging. This is specifically designed for medium and heavy duty fleets. We also support depot deployments behind the fence for both commercial and public sector fleet customers. Again, this is customized turnkey infrastructure that is designed to fit their duty cycle needs. And then finally, there's many fleets where who might not own their land or be able to develop infrastructure behind the fence for any given reason. That's where we have come up with a multi-user charging hub concept to support multiple fleets in a systemized way with infrastructure owned and operated by NextEra. A little bit more about the grant project that we're working on. If you go to the next slide here. I may have frozen here. Oh, there we go. So this is a V2G demonstration project in Northern California. The challenge that we were facing here are, again, greenhouse gas and vehicle mandates in the state of California. And school districts who are adopting electric school buses face higher upfront capital costs, and there are operational challenges related to vehicle scheduling. So as part of this project, the purpose was really to deploy a charging management software solution for 20 buses that could manage charging in an effort to reduce costs, but also to demonstrate V2G capability and evaluate how that fits into the cost stack and how that could potentially drive down costs for school districts moving forward, so that we would be able to scale school bus deployments. We have deployed a V2G capable solution to support 20 buses. It is 5 PCS cabinets with 5 ports for PCS. Again, this is DC charging, and each of those PCS cabinets can support up to 60 kW in charging. Current status of the project, we have completed construction at this stage. We are still waiting for energization from the utility PG&E. That is forecasted to happen sometime in November. And then post-energization, we would install or apply for Rule 21, which would give our bidirectional approval. Touching on learnings a little bit, I would agree with Salim. Don't underestimate the challenges of permitting and construction. We've seen significant delays related to permitting and things, not even related to the EV chargers themselves in some cases, but related to the site itself. We've also run into complexities related to hardware interoperability, particularly related to both the buses and the EV chargers. And then finally, learnings related to market participation itself and how you want to, what program you're participating in, and who are the partners that you're choosing to be able to participate effectively and monetize V2G in a seamless way. So excited to dig into some of those challenges in the session later. Thank you.
I was distracted by listening to you, Ben. I forgot I'm facilitating. Well, let me turn it on over to Krish, at the technology lead manager at EPRI.
Thank you, Commissioner. Hope everybody's doing well. Thanks for this opportunity. I think this is a incredible opportunity to be able to work on this project. My name is Krish Gomatom. I'm the technology lead for a EPIC project. The slide should be coming very soon. This is a project that was funded to advance the understanding and the research required for the trucking industry, for electrifying the trucking industry, just the technologies, the applications, and the gaps that actually exist today in the industry. So this is a very large project. It is a stakeholder-driven project. EPRI, CalSTART, Burns and McDonald, multiple manufacturers, universities, fleet operators, OEMs. So this is a very stakeholder-driven project. Our goal is to listen to each segment that are part of this process, identify what they're saying, assess that as a gap, and then define as much as possible solutions that could address that in the short term and the near term future. Next slide. So just as an overview, so this is called as the California Research Hub to develop high power charging infrastructure along key freight corridors, especially focusing the drayage segment of the trucking industry, which causes significant amount of emissions around the LA port, Long Beach area. So our goal is to not only engage different stakeholders on this project to address their experiences and what they see as gaps, but also define sort of a a roadmap, if you will, for what types of infrastructure, what type of innovative solutions are down the pipe, and what each solution needs in terms of being able to be integrated into this ecosystem of high power charging. So as an example, we have four sectors here that I'm actually showing you this table. We have equity and workforce development. We're looking at how stakeholders who are already in this space are seeing these kind of gaps, and how we can address equity and workforce issues, prioritizing those communities that are impacted the most because of diesel trucking and other types of fossil fuel emissions. Then we have sort of the market needs and technology assessment. This is basically a survey framework where we have spoken to multiple truck OEMs, EVSC manufacturers, service providers, fleet operators, etc., to go in a very systematic manner and understand what their technologies are, what they're using today, what are their experiences and gaps that they're seeing, and what they envision to be the readiness of technology, and also the maturity of technology for actually accelerating the electrification in the trucking segment. Then we have the research and development piece, which is where I have been involved very much so, is to understand what type of R&D activities can be advanced to actually attain to this high power megawatt charging state, and also deploy and demonstrate a few scalable strategies. So there are multiple people involved in this project. I'm just one representative right now talking to you, but we have two pilot sites that are in deployment. One is a MHX site, and the other is a Travel Centers of America site in Ontario, Canada. The other one I think is in Carson, California, and so we are looking at the next gen innovative solutions and trying to deploy them, and then learn firsthand what are the gaps and what are the challenges we're seeing. Next slide. So out of the outreach effort, just in general, at a very broad view, what we see is this transition from CCS to MCS being a major piece to accelerate the trucking electrification. So I think CCS is not going away; it's going to stay. Right now, we have a limit of 1,000 volt DC for this. Maybe it can extend up to maybe 700 amps capacity down the line, but CCS is not going anywhere. And then MCS is going to hit the market in the next 2 to 3, maybe 5 years when you look at production systems. The adoption of MCS is still very it's not concrete at this point, because I think most of the industry, most of the fleet operators, also the OEMs, are actually waiting for how this market is going to grow, and then very importantly, what is the application of MCS, and how does it fit their fleet operation and their logistics? Because every fleet does not need high power. I mean, it all depends on their operation, where they are, and then of course the cost aspect is actually huge. Then we have the utility side of this, where we have the station sizing. Today, 3 megawatt is basically the standard utility connection. Give or take this, 2.5 to 3 megawatts. We anticipate these station sizes to go to 9 to 12 megawatt in the near term, and up to 25, as Salim pointed out. And then this is going to cause significant utility upgrades, and this will have significant lead times, as most of you are already experiencing. Then there is utility, then there's OEMs and cost. Maintenance costs are going to be higher due to certification. The cost initially for these high power charging equipment is going to be high because of the low uptake and volume. But I think eventually the technology readiness scale these sites. And the key question for us is how do you future-proof the infrastructure to be able to scale up, say from 3 megawatts to 25 megawatts, and how the process of interconnection, planning, and permitting, all those are process and procedural aspects that have significant lead times. And then we have this flux of different standards, connector standards. So I think it'll take some time for this to settle. However, I think in the interim we can plan for these gaps and start preparing for a better future. I look forward to more questions down the line, but that's all I had for now.
All right, thanks, Krish. And now Jordan, patent cleanup.
All right, got the mute button off. Thank you. Jordan Smith here. I'm an internal consulting engineer with Southern California Edison. That's what we call our chief technical experts in particular areas. My expertise is in electric vehicles, charging systems, and energy storage systems. Been with the company 27 years, and my part of the company works on technical demonstrations, including our SCE administered EPIC projects, as well as contributions to CPUC EPIC projects, one of which is the e-truck project we just heard about. We are hosting the laboratory facilities in that project. And so I'm going to talk about specifically 3 projects here, 3 of our EPIC SCE administered projects that are focused on transportation electrification. We've got many other projects that contribute to related effects, such as what we would look at with things like DERs and inverter-based generation and grid management system controls. But these 3 are specifically focused on transportation electrification. So I'm just going to do a brief overview of these. And we can go to the next slide, which talks about our what we call our distributed plug-in resources, or plug-in charging resources, if you will, project. And it sort of, as the name would indicate, sort of looks at the combination of customer EV charging devices, in this case, high-power DC fast chargers, and sort of Edison managed devices, and looks at how they could work together to both serve the customer and also help to better manage the grid in the spirit of vehicle grid integration. And so what we've noticed and recorded over the years with studying DC fast charging, individual chargers, as well as the association of chargers that we call a charging plaza, and looking at that data is the load tends to be very sort of spiky, if you will, if you can imagine the needle peaks if you look at the charge profile. And so from a utility perspective, you have to carve off a chunk of the grid to be able to accommodate that peak power, but it may not last for a very long time. So storage can sort of even that out, and from a grid perspective, that allows us to maximize grid capacity for all the customers. And so energy storage has been traditionally used for peak shaving, and so this is not a new idea really, but it does help the customer and it helps the grid. What we're looking at here is actually how we could actually sort of manage that. So SCE operated storage system, if you will, that has a control system that can connect to our grid management system. So we could actually both help the customer and also help the grid. And so we're looking at that. And so from a grid perspective and customer perspective, the load leveling, being able to execute demand response. This is something that in the industry, a lot of people say, oh, well, you can't manage DC fast chargers because the use case is customer has to pull up and get power so that they can be on their way. And so with these types of controls and storage, you could have both, right? Customers could get their charge and be on their way, but we could also manage those grid impacts. We would also have a resource there to provide voltage support and provide reactive power that helps us balance the grid. And we're also looking at resiliency. So how can that system still be in operation when the grid goes down? And so this is all part of our test. We've got the system in our lab right now, and we're getting started on these demonstrations. So a lot of work involved there behind the scenes in all these projects with things like controls, IT, cybersecurity. These are a lot of things that have to be worked out to move into sort of full production that doesn't get a lot of attention. In the next slide, I want to talk a bit about our project called Service and Distribution Centers of the Future, and think back on the WattEV presentation, as well as the e-truck presentation. Also is focused on similar objectives in sort of fueling, electric fueling of these fleets and industrial goods movement facilities in the future. And instead of having gas diesel stations, we have electric fueling stations and electric fueling services. And so this really looks at the depot side of things. And as you saw from WattEV, you have these centers that can sort of start to spring up in an area where we may not even have grid capacity built out because there's nothing there prior to the service station. And so we're trying to work in an integrated fashion with our planning efforts and being able to serve those types of loads. But also the idea is in the future, these types of service may be able to be incorporated with the latest technical efforts. So we have working on technical solutions. And so what we have here is sort of the idea of the controllable or adjustable or dynamic service point. Instead of the traditional way, utility would sort of carve off a chunk of the grid for, again, that sort of peak loading scenario, 24/7, 365. And in the future, we're looking at sort of a dynamic energy service interface, is sometimes called. So we can go to the next slide, which kind of depicts the elements in sort of cartoon fashion. And so what we're looking at here is basically a utility controlled service point. In this case, we're using a microgrid control system that can communicate on site with all of these elements that are shown here. We have a utility owned energy storage system. We're actually incorporating here with our project, with our internal fleet, a mobile energy storage system, which looks at aspects that our fleet is interested in sort of emergency use applications where we need to have vehicles that can go out there and work on the grid, even if the grid's down. And so looking at that element. And then sort of site interface with these various elements, we do have a building electrification portion of the project. And so there's a building management system. And we've got the charge management system that interfaces with the chargers. Not depicted here is something called the fleet management system, which is something that a lot of people don't think about or think to incorporate in systems like this. But these types of systems generally rely on some fleet controls that manage the vehicles and make sure that they can go out and do their jobs and they have sufficient charge to do so. So putting this all together and then connecting on the back end with the grid management system, with the DER management system, part of the grid management system, and all of those controls, and again, cybersecurity, putting this all together is what we're focused on. So we are in the lab phase right now where we've got SEL microgrid control system, and we're running our hardware in the loop tests. We'll progress on to our power hardware in the loop with our microgrid test pad in our Pomona test facility. And we're focused on modeling the system that will go into the field. And that is our Dominguez Hills Service Center, located in a disadvantaged community in a centralized location in Southern California, one of our largest service centers with a large number of vehicles, over 200 vehicles that will be electrified as our fleet moves to full electrification. And so what we look at here is not just how do we provide for that fleet electric depot, but also how does that depot act in a way that supports the local grid. So an interactive approach. We go to the next slide. And the last project that I'll just go over here is our vehicle to grid or V2G interconnection project. And there's sort of two aspects to this project. They're both ultimately focused on getting V2G systems able to interconnect with the rules, the interconnection rules, in a straightforward straightforward manner. But they're also focused on how do you operate such resources in such a way that they can provide valuable grid support. So in both cases, which I'll talk about, we are looking at integration with our grid management system and how we would figure out how we would connect with and utilize those resources as grid assets. So very important. These things sort of precede sort of other things like valuation principles. There are two architectures, the DC or off-board inverter and the AC or onboard vehicle inverter. The latter being one that is in need of a bit more advancement as far as the standards and being able to move into sort of standard order in the interconnection rules. We go to the last slide. And so this is where we are right now. And we do have 3 sub-projects with 3 different OEMs. We have Honda, and we have Bluebird Electric Bus, and we have Stellantis. And the Stellantis sub-project is focused on the AC or onboard inverter architecture. And we've done a lot of work there. There's a lot of engineering that needs to go in the AC format and a lot of standards development. And this project is really focused on an interactive approach with the automakers and the standards bodies to advance that architecture and make it able to connect under regular practice. You can see in the photo here, we've got in the lab now AC EVSE that can perform these specialized functions, as well as a home smart load panel that interacts with the EVSE and the rest of the home, which will be simulated in this case. And so we're getting all that started at this moment. We've got some publications that we've contributed to. The AC EVSE specification was one thing that really helped get started the UL 1741 SC committee. So I'll stop there and back to Commissioner Monahan.
All right, thanks, Jordan. And I think we have about 12 minutes for facilitated discussion. If there are any folks that are listening in as attendees, you're welcome to throw in some of your Q&As. I'm going to just start with a basic question for all the panelists. So I'm just curious about your thinking in terms of scalability. We've done a lot of investments in the V2G space that still seem like there are pretty big barriers to scale. So would love to hear from each panelist, just if you could give like a very short answer to this one, though, because I want to make sure that that we have time for more questions. And Salim, you at WattEV are doing all sorts of innovative things in terms of trucking as a service model. So I don't want to limit just to this project, but just sort of basically, where do you see the biggest opportunity for scalability, and where would you say near term or short, medium term, or long term in terms of actually achieving that scale?
Sure, great question. Yeah, so in terms of scalability, as you know, we've got 4 sites that are under construction and set to open up this year. One of which is already open in Long Beach, which is my background on my profile picture. And then we really take more of a corridor approach towards electrification. So we really follow closely where the routes are going, couple that with grant funding, talk to the utilities to see how much power is available. There's a lot of metrics that go into our site selection criteria. But coming back to scalability, right now, our business model heavily relies on grant funding and incentives to really push those efforts forward. But obviously, you can't plan a business around having grants indefinitely. And really, for us to get to a point where we have mass scalability, we need to see those prices come down and wide adoption takes place. And that's why we're putting so much effort on megawatt charging and talking very closely with the truck manufacturers to push them in that direction, and also created our own charging EVSE manufacturer called Charge America, which focuses only on creating that charging equipment. So from that standpoint, all of our sites are very much future-based. We're planning with utilities to upgrade all of our capacity on all of our sites so that as the demand picks up, we can have those sites available with excess capacity, and then really drive down the costs as we get to mass adoption.
I would expand on that a little bit related to kind of that last point about kind of the hardware availability. I think, you know, what we've seen is every V2G solution right now is really a custom solution when you look at the combination of available EV hardware, EVSE hardware, and then the given utility territory where you're trying to deploy. So I think, you know, I think on the policy side, we've done a good job at setting kind of communication protocols and standards, but I think we need to see some of the hardware kind of catch up to where we are on the policy side. A couple others I would point to from a kind of a scalability standpoint. I think on the construction side, you know, I think something that we deployed on our project was an above grade raceway solution. So we were actually avoiding the need to trench on site, which is, you know, both a cost savings, but also a time savings. I think we're going to have to look at more of those kind of containerized off the shelf solutions moving forward. I also think whatever we can do, you know, maybe there's not a good answer, but whatever we can do to streamline permitting is a huge key to scalability. And then on the utility side, I think greater transparency as you're going through the utility process. You know, our project is taking advantage of Rule 29, but as you're going through the process, the transparency to see where you are at each stage in the process and what the expected time is from the utility associated with each of those steps is something that will help developers greatly, and just, you know, fleet customers greatly as they try to build out these projects.
Yeah, I think just to add to what Ben and Salim mentioned, I think Ben actually hit all the points. The key for scalability, the way that we are hearing from most of the stakeholders, is upgradable systems. I mean, all the systems beginning from the utility side all the way down to the dispenser, all these systems are designed with a fixed output in a fixed configuration. I mean, we have to get to a point where these can be interoperable. These can be plug and play to some extent, and they can be modular and expandable. So one thing that Ben mentioned is, like, you know, things like containerized systems or package systems where, you know, where you can have a 1 megawatt charger system, but it could be easily upgradable to 5 megawatts. You know, that's one issue. The other issue also is looking at medium voltage connected converters. So most of our converters today are 480 volts input. So that actually puts a limit of about 3 megawatts on the station size. So the idea is, if we go higher up in terms of input voltage to either 11 kV or 13 kV, we could significantly increase this capacity. We may not use it right away, but we could use it in a scalable manner. Thirdly, it is the chargers itself, where I think there needs to be innovation and some technology development in making these chargers buck boost. You know, buck and boost. Right now, most of them are in the buck mode, which means that they can only feed 1000 volt DC. So we kind of max out at 1000 volt DC in terms of delivery of DC power. But to be able to make them beyond 1250 or even 1500 volts, even if you have liquid cooled cables and stuff like that, I don't think the chargers are ready yet. I mean, there is no significant demand for it, but I think being able to plan for those type of technologies would be something that will help scalability.
And as far as V2G specifically, that's something we've been working on for quite a long time, actually, many years on V2G. And I think, you know, we've gotten to the point now where under Rule 21, you know, the parties have agreed that you know, DC or the offboard or DC charger type V2G systems can interconnect today under the existing Rule 21 procedures. And so that I think is a good achievement there. There are 4 products, as I recall, V2G chargers that are on the SCE APL for our Charge Ready program. And so there's products out there that customers can purchase that are V2G capable and able to interconnect. So I think that's a good achievement. There's sort of a scale of things when it comes to V2G, sort of a scale of operation modes, if you will, for V2G. So it's everything from sort of a backup generator type application all the way up to like a energy market grid trading, which we demonstrated in the LA Air Force Base V2G project back several years ago. And we're starting to see commercial product come out there. The Ford Lightning is one example, which is offering a home connection V2H, or if you will, backup power system. And so that's something customers can also adopt, install, and interconnect today. So I think it's always V2G. It's always been sort of a market consideration where the automakers or vehicle makers kind of struggle with building in and offering to customers the V2G features, and some uncertainty on whether customers are going to go and purchase those features. And so I think probably getting the cost down of those systems so that it's not so much of a expense for customers, and maybe these capabilities are pretty easy for customers to adopt. And then I think from that point, customers get the equipment and get it installed and interconnected, then we can start exploring some of these other features like grid support and that type of thing. But it's really hard when there's, we on the utility side are looking at this and saying, wow, this would be really great. And I think we have 500,000 EVs in our territory is the estimate, latest estimate. So it'd be really great if we could utilize some of these EVs, which are kind of rolling energy storage, for some of these grid support applications that we think about. But how do you bring that together and aggregate it and control it and actually put it to effect? So I think that's part of the challenge in scaling up.
So I only have 2 minutes left before we're supposed to turn over to the audience Q&A. So I'm gonna ask you all to be really disciplined and just give no more than 2 sentences of an answer. And my question to you is, what is the sort of #1 either research investment or barrier busting that should be done to be able to advance your project, whether it's WattEV's work around integrating battery storage plus solar and providing truck service, whether it's V2G, whether it's sort of mapping out what we need heavy duty vehicle charging space. Just 2 sentences on that question. That's basically advice to
I can go first. So I think it boils down to interoperability. So kind of Jordan, as you were talking, I commend the CEC and the other IOUs in California for coming out with the APL. I think that's a step in the right direction. I would say the V2G hardware options on the APL are very limited, and I think I'd like to see us move towards a greater emphasis on interoperability, not just looking at kind of approved products in isolation. So I would say it boils down to that as the biggest issue.
That's great. If I could tag onto that, which I agree with, I would say if I was kind of try to focus in on 2 sentences, would be around that interoperability, but also the controls interoperability. And the cybersecurity is really something we spend a ton of time on, and it doesn't get a lot of attention. And so I think that's one of the barriers that we really need to get to that interoperability Ben talks about.
If you're only limited to technology rather than policy, Yeah, I mean,
Don't feel limited.
from a technology standpoint, it really goes back to having planning for the future. And one of the projects that we are working on is a medium voltage system for both CCS and MCS, where you have medium voltage going directly to a power cabinet, and then that power cabinet can dynamically share power between both CCS and MCS connectors. And then being able to couple that with distributed energy resources or other power sources. And then on the policy side, it's really just coming up with solutions on how to accelerate the electrification. I mean, there's a number of bottlenecks and limitations that we've seen, and Ben had touched on some of those on the utility side that I think we can work towards to accelerate. I mean, for one, we've seen some challenges where offloading some of the responsibilities to the customer may help accelerate it. I mean, I've seen issues where supply chain has been used as a catch-all excuse, where in reality we've seen close to 10-15 weeks for getting a switchgear rather than what utilities have told us.
Okay, that's
Yeah, I
I
think-
want to talk to you after about that, Salim. Krish, go ahead.
Yeah, no, I think most of them got all the points. I think one thing I would say is more demonstrations, more understandings about performance of medium voltage connected megawatt charging solutions. One thing that is not being highlighted enough is remote monitoring and diagnostics, to be able to keep these charging systems up and ready always, and be able to have some sort of a self-healing systems in this, so that if they go down, there's a way to know that. Lastly, I think there is a great level of divide. I mean, I wouldn't say divide, but there's some friction between utilities and technology providers, manufacturers. I think we have to bridge that divide. Maybe there are some utility private partnerships. Maybe there's a way to influence utility, like the regulatory commission, to understand why, because utilities know this. I mean, they know how to manage these power cabinets and the infrastructure, and they have done that for years. Let them handle that. Let them own and operate that equipment, and then have some sort of a leasing arrangement or something which would allow the private companies to just operate these stations, rather than having to deal with all the supply side issues.
All right, thanks, everybody. So we're at the audience Q&A portion. So if you have a question, there's some already listed, please feel free to throw it in there. And I'll just start with, let's see, the first one is about hydrogen versus EVs for medium heavy duty trucks. I'm not sure if anybody on the panel has that expertise.
We actually studied hydrogen before we created WattEV, and for us, it didn't really make sense from a number of standpoints. At the time we were looking at it, what hydrogen offered in terms of the benefit was faster fuel times and possibly longer range. But the more we ran the numbers to actually create green hydrogen using electrolysis and solar and battery storage, the more we realized it doesn't make sense from a business standpoint. You're spending a lot of resources and money on the equipment to get ultimately a lower energy density than you do with battery. And when we started looking at the transportation costs and what it takes to also create liquid hydrogen, it's extremely costly compared to getting battery or energy from the true source. And that's when we started looking at where battery technology is going with megawatt charging and battery density getting faster. And that's when we made the decision to pivot and focus exclusively on EVs.
What I would say is I think battery electric makes a lot of sense, especially for regional use cases, and that's the majority of what fleets are doing. They're going less than 100 miles a day. So I think in a lot of cases BEV makes sense. I think from an energy density perspective, hydrogen is pretty attractive, and I think it remains to be seen kind of what's settled in the truly long road trucking sector. But that's how I would respond there.
Right, so the next question, I'm going to boil it down quickly, is whether with, especially I think, big charging plazas of either probably light or medium heavy duty, and the need for resilience, shouldn't renewable energy and storage capacity be a requirement rather than just an add-on? Anyone have a response to that?
Comes down to the economics, right? Adding battery storage is going to be costly, and you have to see what your utilization rate is expected to be. And at some point, it may make sense to add battery storage so that you have more resiliency as well as ability to do peak shaving.
I think that you know, it'll sort of naturally evolve that way with customers, and we're seeing this. You know, we see this with WattEV and others. Is when you look at how do you operate facilities like this, you kind of get driven to that solution, that you'll want to have storage and probably some generation in the future for these types of facilities.
Yeah, I think one question that is also out there is about the integration of DER, whether on the DC side or on the AC side. So if you're talking about DC hubs or DC bus enabled systems, and the whole value proposition for them is to be able to integrate storage easily without having to have a storage inverter, for example. But I think even with any kind of DER integrated into the system, it all comes down to utilization and how much peak. I mean, peak mitigation is the only use case that we have seen with battery storage. There might be others that might evolve down the line, unless there is a way to export storage that is integrated on the DC side. But then that's actually very complicated to again invert that and then send back to the grid. So I think V2G is the beginning enabler, and then you have storage. But I would probably say if we go down that path, V2G should be a requirement rather than storage. That's just my view. Because V2G makes it more flexible to be on the grid, and then the grid operator can actually use it as a resource to actually call that resource.
But Krish, it sounds like you would be leaning towards a policy where we move eventually towards all vehicles being V2B, V2G, V to something requirement.
Probably so. I think there are still challenges in that space, but I think eventually use cases will become more economically viable. But I think again it's fleet to fleet. It is logistics based. How much utilization, how much traffic you have, and things like that. So the costs will have to play out. But I think if there is a value for supporting the grid, and if that value is appraised on the storage system, it might become more economically attractive.
Yeah, I would expand on that. Maybe a slightly different view. I don't necessarily think it makes sense for all fleets. I think there's a sweet spot with the highest V2G potential that's based on fleet characteristics, your utility and ISO territory, and then also the charging hardware itself. So there are a lot of fleet kind of use cases where V2G wouldn't really make sense based on the combination of the charging hardware that you're going to see and kind of their dwell time, seasonality, things like that. But there are a lot of use cases where it makes a lot of sense. Like school buses are one of those that's is kind of in that highest V to X potential bucket. So I think you have to take kind of a segment or segmentized approach when you're thinking about that potential.
There's a wide spectrum there, and yes, school buses seem to have a nice duty cycle. There's some others, but some, if you have really high vehicle utilization, we're starting to look at some of this data, and you run into situations where there's just not enough time to charge off peak, and so lacking any kind of storage or other controls, some of those big trucks with heavy duty cycles end up having to charge on peak. So that's not what we're looking for to sort of add to peak demand. But there's a wide spectrum there. I think school buses is an obvious one to further investigate.
All right. Well, I think then I'm not going to read the next question, but I'll just say there was a question about an executive order from the governor calling upon state agencies to buy bidirectional EVs and systematically integrate electric school buses as a resilient strategy. So sounds like there may be some opportunity in that space, but I want to thank the panelists for a great session today, and an issue near and dear to my heart. I really hope we can move more swiftly towards this future where EVs really are good citizens of the grid and maybe even give energy back when we need it. Just want to thank all the folks that have listened in to this session and all day long. We're ending our 2023 Epic Symposium. This is our last session. So thanks to everybody for joining. These are all recorded and are going to be available soon. So hope you enjoyed it and come back next year. Thanks, everybody.
Thank you.
Thank
So-
you.